So whenever you are studying any type of mechanics, either this is classical mechanics or quantum mechanics, statistical mechanics, so roughly there will be 5 questions. You are going to answer these 5 questions like how to represent the state of the system. So first objective, whenever you are developing, particularly here we are concerned with quantum mechanics. So first question that will be in your mind, that in quantum mechanics, how you are going to define the system. So my first question is, which I have to address, how to define the state. How to define the state in quantum mechanics. First thing is this. Second, how to represent the physically measurable quantities. In mechanics, you are going to observe various physically measurable quantities, like position you can measure, position of a particle, momentum, angular momentum, energy, and many more. Okay? These quantities, these physically measurable quantities, in quantum mechanics you call them observables. In quantum mechanics, these physically measurable quantities, they are called as observables. So second question will be, how to represent physically measurable quantities. Physically measurable quantities. Quantities called observables. In quantum mechanics, they are called as observables. For example, position, momentum, energy, etc. Energy, angular momentum, etc. This is you. So first you have to define the system. Okay? Then you have to define the physically measurable quantities. So you have defined momentum, you have defined position. So next question is, how to measure these quantities when system is in a particular state. So next question will be, you have defined the state, you have defined the physically measurable quantities. Now next question will be, how to measure these physically measurable quantities, how to measure observables when your system, quantum mechanical system, is in a particular state. So next will be, how to measure observables. How to measure physically measurable quantities. Physically measurable quantities. This is third question that you have to answer. In quantum mechanics, you are going to search these answers. These are the questions you have to find out their answer in quantum mechanics. Next, when you are measuring a physically measurable quantity over a system is in a particular state, you are measuring some physically measurable quantity. Then you are doing this repeatedly. I am measuring momentum. After some time, I am again observing, measuring momentum, and again I am doing this process. So I am measuring physically measurable quantities again and again when system is in a particular state. Will I get the same answer every time? Okay? If you are getting same answer every time, then there will be no problem. You will say, okay, when system is in this state, this is the value of momentum. But suppose you are not getting the same answer every time. then what will be the value of the observable? What will be the value of momentum? You are measuring momentum. Every time you measure momentum, you are getting a different value. So now question is, when you are getting, every time you are getting different values, then what will be the value of the momentum when system is in that state? This is your next question. We are going to search these answers through postulates. These postulates are actually the answer of these questions. Okay, so you can write fourth point. लिखिए. Do all possible measurements of an observable in a given state lead to same numerical value. Lead to same numerical value. Lead to, I'm repeating, do all possible measurement of an observable in a given state lead to same numerical value? Question mark. So you are doing measurement of a observable again and again. So either you are going to get the same value. आगे लिखो, if not, then what will be the value of the observable in that state? Then what will be the value of the observable in this state? That is the fourth. This is fourth one, beta. So it is related to repeated measurement, and in repeated measurements you are getting different values. So now there will be a question, out of so many values, what will be the value of that observable when the system is in that state? So you have to answer that. And last, if you can define a system at time t naught, you have defined psi at t naught, then what will be the state, or what will be psi at a time t greater than t naught? Means how your state is going to evolve. Okay, next question is how the state of the system is going to evolve. So next question is how the state of a quantum mechanical system will evolve. That is how the state of a quantum mechanical system will evolve. That is if we know the state at time t naught, that is if we know the state at time t naught, then what will be the state? Then what will be the state at time t greater than t naught? Then what will be the state? How to write psi? ठीक है ना, at time t greater than t naught. Then what will be the state at t equal to t greater than t naught? So what I am saying, I want to say this. Suppose I know this psi, जैसे आप psi xt से करते हो ना, I know this. Here position is x, time is 0. So if I know this, then I should be able to write psi xt. This will be the next. This is called as evolution of the state. At time t equals, suppose t naught is 0. It's not necessary that t naught is 0. But suppose initially I know this psi is given to me, and I'm saying you please write psi xt, wave function at time t of the system. So we are in search of these 5 questions. Okay? So you have to define the state. You have to learn how to represent the physically measurable quantities. Next will be how to measure these quantities when system is in a particular state. Next will be, if we are measuring again and again, we are getting different values, then what will be the value of that observable? You say that okay, this will be the momentum. मुझे तो एक value चाहिए. ठीक है? Then how we will actually write the value of the observable in that state. And in last, suppose I know the state at some time, then what will be the state after some time? Right now I know the state, suppose, then after some time, what will be psi? I just want to know this. This is our objective here of these postulates. So one by one, we are going to answer through postulates. So first, postulate 1. I'm going to start with postulate 1. Postulate 1 beta. First is, postulate 1 is specification of a state. You can write here specification. Answer of the first question. Specification of a state, of the state. Now, here in quantum mechanics, what is the problem? Okay, we start with classical mechanics, suppose. In classical mechanics, how you define the state? In classical mechanics, we define the state by two coordinates. One is position, another is momentum. Why you are able to represent like this? Because you can measure position as well as momentum at the same time with 100% accuracy. Okay? Why you are defining in that way? Because you can measure both of them with 100% accuracy. So in classical mechanics, we define the state by x comma p or r comma p you can write. This is the way. But in quantum mechanical system, when we are at a microscopic level, particles are very small, we are at microscopic level, there is uncertainty. Uncertainty exists. You cannot measure the position with 100% accuracy. At the same time, you cannot measure the momentum with 100% accuracy. If you try to improve the accuracy in the measurement of the position, then uncertainty in momentum is going to increase and vice versa. So this is a problem in quantum mechanics. So basically here problem is that we cannot measure position and momentum with 100% accuracy. So due to this reason, we cannot define the state by x comma p in quantum mechanics. The reason is this, because when you cannot define something with 100% accuracy, then how can you define the state in that way? So in quantum mechanics, a different approach was applied, and a mathematical, a mathematical function, or what should I say, mathematical क्या बोलते हैं उसे, called mathematical object. A mathematical object was introduced. So basically I will dictate, don't worry here. So here a mathematical object लिखने का जरूरत नहीं है, I will dictate, was introduced, that is written as psi. Okay, you write it psi, and this psi will be a function of position. So I am writing r. When I am writing r, it means x, y, and z, as well as it will be a function of time. It will be a, and what is important here? This will be a complex function, and it will have all the information about the system, not only at time t equal to 0, but also at time t equal to or t greater than 0. This has all the information about the state of the system, not only at the present time, but what will happen in future at time t. So, and what is its physical significance? Next question is, define to kar diya. What it is representing? Exactly, it doesn't have a physical significance at all. ठीक है ना? अगर आप इसे, कुछ लोग बोलते हैं this is probability amplitude, but in general this is not having any physical significance as it is. But if you make the square of this psi square, if you make the square of this and you want to find out that, okay, tell me the probability of finding the particle in a given volume dV, dτ, then probability of finding the particle in a small volume dτ, that will be given by this. This has a physical meaning. Exactly, you are going to represent psi, but psi itself doesn't have any physical significance. So we have to bring some physical significance, otherwise what's the meaning of defining it? Its physical significance is here in this way. So if you make the psi square and multiply this by dτ, dτ is the small volume, then this will give you the probability of finding the particle in this small volume dτ, in this volume element dτ. So this is having the physical significance. This was given by this interpretation, it was given by Born. Okay. So this quantity is having physical significance. Now what you are doing, what this is telling me, this is telling me the probability of finding the particle in this volume dτ. So if you look at this only psi square, what it will be? This will be probability density. अब density को क्या करते हो? You multiply density with volume, you get the mass. Here you are multiplying this quantity with this volume, you are getting the probability of finding the particle in a small tiny volume dτ. So what is this? This is called as probability density. That's why they are calling it as probability density. So psi square, this is actually probability of finding particles, of finding particle in a volume, in a tiny volume dτ. dV भी लिख सकते हो, you can also write it as dV. Now, because volume is multiplied by this quantity and this is giving me probability, so we are going to define this as probability density. So this is called as probability density. Now, as in case of intensity, how you define intensity? In case of light, light are also waves, you write I as A square, amplitude is square. Amplitude square gives you intensity. So by the simple that type of correlation, you are saying that this is probability density. So some of the people, not in all the books, some people call that, okay, this psi, this can be called as probability amplitude. So you make the square of this amplitude, this is giving you probability density, you multiply this by volume, that will give you the probability. Amplitude. Okay? So if you are having three-dimensional problem, then you are having psi square dτ. If suppose your particle is in two dimension, a particle can exist only in two dimensional, you are considering a two-dimensional problem, then in place of this dτ, you will have a volume, area element. In place of this, you can have this time this will be psi square and you call it as dA or ds, whatever you want to write. This is area element. So this is the probability of finding the particle in this small tiny area element ds or dA. Okay. Now what will be the probability of finding if you are having one-dimensional problem and you want to find out the probability of finding the particle in between x and x plus dx. It means you want to find out the probability of finding the particle in between these two, x and x plus dx. So this length is dx. So probability of finding the particle in this dx distance length, that will be psi square, and this will be dx. So it depends upon. So this probability depends, either you are dealing with 3-dimensional problem, 2-dimensional problem, or 1D problem. So if you are considering 1D problem, your particle is trapped in 1D. So you are going to use this. If you are having 2-dimensional problem, then this. 3-dimensional problem, then this. Okay. Now suppose you want to find out the probability of finding the particle in between x1 and x2. So here, this is the probability of finding the particle किस range में, from x, this is x here, and this distance is x plus dx. So in this length element, you want to find out the probability of finding the particle, that is this one. But your next question will be, suppose I want to find out the probability in between x1 and x2. I am considering 1D problem to explain you. I want to find out the probability of finding the particle between x1 and x2, not a element, but x1 to x2. Then simple. In that case, my probability will become the integration of this psi square dx, and you are going to provide the limits x1 to x2. ठीक है? Now, what is this? This is probability of finding the particle in this range. Probability can have a maximum value of 1. Maximum probability कितना होता है? 1. So, if you are having a particle, automatically it will exist somewhere. ठीक है? For example, in 1D potential well problem, what you say, my particle is trapped in a well that exists from 0 to A. So surely particle is going to exist in between 0 to A, कहीं ना कहीं तो मिलेगा मुझे. Suppose this type of thing is not there, then you will say, okay, my particle will be somewhere from minus infinity to plus infinity. कहीं तो exist करेगा. So if I integrate this quantity, ठीक है, if I integrate this quantity from minus infinity to infinity, and I write psi square dx, then it should be equal to 1. It should be equal to 1. ठीक है? So first thing, what is needed here, try to understand. If you want to define probability in this way, or you want to define like this, that my particle is existing in between somewhere in the space, somewhere in the space particle will be there. So if I am integrating for the complete space, minus infinity to infinity, so surely particle will be there, and this is 1. But what is needed here? Normalization. Before that, your function should be square integrable. Your function should be square integrable. ये जो है ना, ये square integrable होना चाहिए. So how you define square integrability? In 2 ways you can define it. ठीक है? In 2 ways you can define it. First is psi. It may be x, y, z. X, Y, Z. And if you are moving this x, y, and z towards infinity, ठीक है ना, you are placing the limit that x is moving towards infinity, y is moving towards infinity, then your wave function should die out. It should tend to 0. ठीक है ना, then it should tend to 0 in this limit. So if you are having a wave function, then it should be 0 at infinity. Otherwise, your psi square will become infinite. So first thing is this in square integrability. Second, if you are writing psi square dx, it should be less than infinity. Means it should be finite. It should be finite. तो अगर ये finite है, suppose you are getting some number, you can bring that number on this side. Try to understand why it is needed. ठीक है? Because if it is finite, suppose here on this side, on solving this, I am getting a or a square, suppose. So I will bring that a square here. So it will be 1 upon a square. ठीक है? And I will combine 1 by a with psi. So if I make my wave function as 1 by a into psi in place of psi, then this integration, it will be equal to 1. So because maximum probability is 1, ठीक है ना? That maximum probability 1 is possible only if your wave function is square integrable. So first thing is this should be square integrable. First it should tend to 0 when we are moving towards infinity. Otherwise this will blow up. It will move towards infinity. ये नहीं होना चाहिए. Second thing is it should be finite. Only then I can make this condition. Here when you are writing this condition, this is normalized. But इसे 1 कब हो सकता है ये? Only when this is actually, this was something like this. This was finite. Then I can normalize it. जो आप normalize करते हो, then you can normalize it and you will introduce some constant with psi and then you will have a normalized wave function. And for normalized wave function, this will be 1. So this condition will be matched. So one important aspect when you are defining psi is that your wave function should be square integrable. ठीक है? So you are having complex wave functions. So we are working in a complex space. So what type of, you are having so many wave functions here. You will have psi x, you will have phi x, you will have chi x. So many complex functions will be there. You are clubbing them together in quantum system, in some quantum mechanical system. All of these wave functions, they are complex in nature. First thing. So whatever space you are creating, that is complex in nature. Next thing is, okay, second aspect is they are all this psi, because we will deal in terms of probability. So they should be square integrable. They are going to be square integrable. So in what type of space we are going to work? We are going to work in a Hilbert space. So elements of this Hilbert space, they are complex in nature. So we are working in a complex Hilbert space. All wave functions, all the wave functions here, they will be square integrable. They will be square integrable. And we will find out, it will also be required that this space, this linear space which we are creating, this will be equipped with scalar product. उसका जरूरत पड़ेगा अभी सुपरपोजिशन में, ठीक है ना? So we need a type of space in which all the elements are complex. Second, all the wave functions or these elements, they are square integrable. And this space, this linear vector space, it should be equipped with the scalar product. So this type of linear vector space is called as Hilbert space. So you are going to work in the Hilbert space here. ठीक है? तो आप Hilbert space में काम करते हो. Dimension कितना होता है? Infinite dimension. The reason is you are having psi x. So for x you can change x. X can continuously change. So you can have so many basis vectors. So it will be infinite in number. So dimension of this Hilbert space, it will be infinite. Infinite. So in this way we start developing this. फर्स्ट पोस्टुलेट, ठीक है ना। हाँ जी बेटा बोलिए। हो सकता है, it may be, but here in general we are going to deal with complex. It may be real also, ठीक है ना. So your wave function can be real also. So many of the wave functions they will be real, ठीक है ना. तो जैसे for example this one, you know this problem 1D potential well problem. What is the wave function? Psi equal to square root of 2 by L sine n pi x upon L. So that is a real wave function. So it may be real, but in general complex is there, it may be real also. So this is now. So we have defined psi to some extent. Now we are going to give it some characteristics. What will be the properties of this psi? ठीक है ना. For acceptable wave function, what should be the properties? So you are, suppose I am giving you this is the volume, ठीक है ना. This is the volume dV. So can you tell me this psi can have two different values? It can be double values? No. It will be a single valued function. Psi will be a single valued function. Why? Otherwise, in this volume, you are going to get two probabilities. Why psi should be single valued? Otherwise, when you are calculating probability and you are having two different values, so at a particular point, you will have two different probabilities of finding the particle. That is not possible. At one position, there should be single value of the probability. So psi should be single valued functions. Second, psi should be finite valued function. Psi should be finite valued because this has to satisfy this condition. Otherwise, it will not remain square integrable. ठीक है. Next will be, ठीक है, it should be continuous. ठीक है ना. It should be, psi should be continuous. So if you are having some region, psi should be continuous. ठीक है. And it should be square integrable. I have already told. So these are the four properties that psi should follow always. A physically acceptable wave function should satisfy these four conditions. It should be single valued. It should be finite valued. ठीक है. Third, it should be continuous. And fourth, it is square integrable. Many times you will find out that they are satisfying first three, but they are not square integrable. So that wave function is not acceptable. So this is all about this psi, जिसका हमें जरूरत पड़ता है. Yes, but Dirac delta function. You can define psi for that. ठीक है, you can define psi for that. For Dirac delta, there is Dirac delta potential. ठीक है, there is a separate problem for this. When we will deal with 1D problems like step potential problem will be there, barrier potential will be there, this well will be there. ठीक है, and then there will be a problem, this Dirac delta potential. ठीक है, so that will be there. Now you can start writing. Postulate 1. You can also write, some people write statistical interpretation of this wave function. So please write. लिखिए बेटा. The state of a quantum mechanical system. The state of a quantum mechanical system at a given instant of time t. At a given instant of time t is completely defined by a mathematical object psi rt. RT, which is called wave function, which is called wave function. Which is called wave function. Number 1 करके लिखो बेटा, या नंबर 1 से पहले लिखो. This wave function has all the information. This wave function has all the information about the position of the particle. This wave function has all the information about the position of the particle at any arbitrary time t. At any arbitrary time t. Then number 1. Number 1. Wave functions are, number 1, wave functions are complex valued functions. Wave functions are complex valued functions. In general, real भी हो सकते हैं, ठीक है ना? Real is a subset of that. Complex is having both. So, number 2, psi RT doesn't have any physical meaning in itself. Psi RT doesn't have any physical meaning in itself. However, some people say it probability amplitude. However, some people say it probability amplitude. Some people say it as probability amplitude. Say it probability amplitude. Number 2. Number 3. 3. The probability of finding a particle, the probability of finding a particle at a given instant of time t in an infinitesimal volume d tau, in a infinitesimal volume d tau is given by yes beta, the probability of finding a particle at any instant of time t in an infinitesimal volume d tau is given by psi RT square into d2. ठीक है? This is the probability of finding the particle in this d2. So this is volume and you have multiplied this. Next point. ठीक है? Now, how should I write? From the third point, from the third point, we can observe that. This is fourth point actually. From the third point, we can observe that psi RT square is representing the probability density. Is defined as probability density for locating the particle in space, space at a given instant of time. At a given instant of time. ठीक है? Now, next point, fifth point. If we integrate psi square deta, if we integrate psi square deta for the complete space, if we integrate psi square deta for the complete space, then it will be equal to 1. Then it will be equal to 1 because particle will exist somewhere in space. Because particle will surely exist somewhere in the space. So total probability should be 1. So next is this one. So full space. So this will be psi RT. This should be 1. This should be 1. Because this condition is called as normalization condition for the wave function. This condition is called as normalization condition for the wave function. This condition is called the normalization condition for the wave function. And the wave function satisfying this condition, and the wave functions satisfying this condition, and the wave functions satisfying these conditions are called normalized wave functions. Are called normalized wave functions. Normalized wave function. Next point. Next point. If we multiply a wave function psi with a complex quantity e to the power iota alpha, if we multiply the wave function psi with a complex quantity, not any, this type, with a complex quantity e to the power iota alpha, then probability density or probability of finding the particle doesn't change. So what I am saying, you are saying that this is psi. So you are getting, how you are going to get psi square? This will be psi into psi. So this will be psi square. Okay. Now you multiply this psi by e to the power iota alpha. So what will be the complex conjugate? It will be e to the power minus iota alpha psi star. ठीक है ना, psi star multiplied by e to the power iota alpha psi. So earlier you are having psi, so you find out psi square. Probability density was psi square. Now you multiply this psi by e to the power iota alpha. So you will, if you will make the square of this, ठीक है, then you will get this. So क्या होगा इन दोनों का multiplication? That will be psi square itself. So probability density or this one, probability of finding the particle in this volume is not going to change by the multiplication of this type of factor. This is another property of this. Next लिखो बेटा. Next लिखिए. The condition of normalization. The condition of normalization requires that that all the wave functions should be square integrable. All the wave functions should be square integrable. Should be square integrable. That is limit x comma y comma z tending to infinity. This psi x y z t, it should tend to 0. This is one of the definition. You can write it as A, and B, the psi square theta minus infinity to infinity, it should be less than infinity. It should be finite. It should be. These are two different definitions, but both are saying same. These are two different ways to write the same thing mathematically. This is another point. Next point. In general, a physically acceptable wave function satisfy the following conditions. Condition A, point A, the wave function must be single valued. The wave function must be single valued. B, it must be continuous. It must be continuous in the entire region of its argument. In the entire region of its argument. Arguments kya hai? Arguments are these. Like here you are writing in bracket, psi is a function of independent variables, means x, y and z. So x का जो limit है, whatever is the limit of x, whatever is the limit of y, whatever is the limit of z, in that limit it should be finite. Argument is this. Next लिखिए, it must be finite everywhere. C point. It must be finite everywhere. D point. The wave function must be square integrable. The wave function must be square integrable. Next point. All the wave functions, this is next point, fifth point. क्या बेटा? Ninth? They were A, B, C, D, 4 were together, and this is next one. Number पता नहीं मुझे. ठीक है ना? It will be fifth or sixth, जो भी है, whatever it is. So लिखिए बेटा. क्या बोल रहा था मैं? क्या? अच्छा, all the wave functions, लिखिए बेटा. All the wave functions which are in general complex in nature, which are in general complex in nature, forms a linear vector space. Forms a linear vector space. Forms a linear vector space. Full stop. All these elements, और ब्रैकेट में लिख लो wave functions, all these elements are square integrable, as well as they are equipped with scalar product or inner product, as well as they are equipped with scalar product or inner product, in bracket, to follow superposition principle. In bracket you can write to follow superposition principle, bracket close, bracket close. It means in quantum mechanics, we are working with complex Hilbert space. We are working with complex Hilbert space of infinite dimension. ठीक है ना, of infinite dimension. Next point, unit of normalized wave function. Unit of normalized wave function. Next point. This is all about these wave functions. Units of normalized wave function. So इसका unit क्या होगा? It depends upon in how many dimensions you are working. Suppose you are dealing with 1D problem. ठीक है? So I'm writing here a 1D problem. So my wave function psi square, it will be dx and this will be equal to 1. ठीक है ना? This will be 1 from minus infinity to plus infinity. What is this on the right hand side? This is probability. क्या होता है dimensional unit? It is dimensionless. ठीक है ना? Probability is the ratio, dimensionless quantity. So this should be dimensionless. Psi square dx, this should be dimensionless. So what will be the unit? Because this is dimensionless, product of this is dimensionless. So dimension of psi square, dimension of this psi square, you can write. This will be 1 upon dimension of x. Dimension of x. ठीक है? तो dimension of this psi, dimension of psi, it will be simply 1 upon length to the power half. So unit of psi कितना होगा बेटा? इक्वल टू, यू कैन से मीटर टू द पावर -1/2. ठीक है? यही होगा, मीटर टू द पावर -1/2 बेटा. इस तरीके से, या 1/2 जैसे भी लिखना हो आपको. 1 by meter to the power 1/2 or this way. Now suppose you are dealing with 2D problem, then it will become minus infinity to infinity. This will be psi square dx dy, and this is equal to 1. So this quantity is dimensionless. इसका dimension कितना होगा? Length. इसका भी dimension corresponding to length. So what will be the unit of psi, or ये कितना होगा, या dimension of psi here in this case? It will be 1 upon length. ठीक है? ये भी length square हुआ ना, and psi square you will make the square root of this. This will be 1 by length. The unit of psi in two-dimensional case, it will be meter to the power -2/2 or meter to the power -1. ठीक है? Now what will be the unit for 3D case? You can write yourself. This will become dx dy dz. So this will be length to the power 3/2. ठीक है? So how much? What will be the unit of psi? This will be meter to the power -3/2. It will be meter to the power minus 3 by 2. You can write yourself for 3D case. Next लिखो for n dimensional case. For n dimensional case, this will be psi square. You can write in this way. This will become psi square for the space. Psi square dx1 dx2 up to dxn, and this will be equal to 1. So its dimension of psi, it will be equal to 1 upon length to the power n by 2. This will become, ये हो जाएगा बेटा, ये हाँ प्लस हो गया. तो what will be the unit of psi? Unit of psi, this will be equal to meter to the power minus n by 2. So for 1D this will be 1 by 2, for 2D 2 by 2, for 3D 3 by 2, for 4 dimension 4 by 2, it will be like this. ठीक है ना? So this will be the unit of psi. Unit of psi. You also need one more thing. Sometimes in numericals you can write this property. If you can write one more property of psi. If psi1 and psi2, if psi1 and psi2 are two continuous functions, if psi1 and psi2 are two continuous functions, then psi1 plus psi2 comma psi1 minus psi2 and psi1 psi2 will also be continuous. ये continuity में पढ़ाते हैं आपको मैथ्स में 12th क्लास में, शायद 11th में. will also be continuous. वो fx fy लेके पढ़ाते हैं आपको, ठीक है ना? will also be continuous. Full stop. However, this rule is not applicable for division. However, this rule is not applicable for division. If psi1 and psi2 are continuous, then it's not necessary that psi1 by psi2 or psi2 by psi1. It's not necessary that they will be continuous. But these three, they will be continuous. This is very useful. If sometime lengthy type of wave functions are there, you want to check it, either this is continuous or not. So you split it into two parts, which are known to you. दोनों को अलग अलग देखो. If they are continuous, automatically product of these two will also be continuous. ठीक है? So this is all about psi. जितना हमें चाहिए. This is first postulate. This is first postulate. But here we have defined how we are going to represent the quantum mechanical state. So quantum mechanical state, it will have all the information about the position of the particle. Suppose this is the nuclei, electron is revolving like this, and you have written the psi for the ground state. Then this psi will have all the information about this particle. But that information will be in terms of probability. Exact location it is not going to tell you. Okay, at this particular time it will be at this location. But it will surely tell you the probability of finding the particle at some time in a given region. It will tell you. So that's why जो quantum mechanical plots जो देखते हो, they are in the form of clouds. ठीक है ना? Those clouds, they are representing the probability actually. So that type of thing is there. So basically it will have all the information of the particle and the state in which it is. Okay. So you are going to represent the state of the electron in the ground state, you are saying, then you can write the wave function of that ground state. You will be able to write down the wave function of the ground state. If it is in the first excited state, you can you will be able to write down the wave function for the electron when it is in the first excited state or second excited state. It will have all the informations. So you are going to define psi 1, psi 2, psi 3, psi 4 like this. Or you can write for n, substitute value of n like 1, 2, 3, 4. So in this way you can define. So my first objective was to define this psi. If you are having a 1D box, you are going to have psi 1, psi 2, psi 3. You will be able to write. Okay. Everywhere where particle is there, you can write its wave function. Even if a particle is free particle, even you will be able to write down its wave function. तो सबसे पहले यहीं से शुरू करते हैं. In 1D case, you will have a free particle. You have to write down the wave function of this free particle. सबसे पहला wave function जो आप define करते हो, that will be for the free particle. Then you start trapping it in some regions, and then you start writing those wave functions. So first you have defined, okay, in this way, in this manner, I am going to represent the states. अभी इस state में मुझे, I am saying my electron is in the ground state. I have written the wave function. Then I should be able to find out the velocity of the electron in that state, energy of the electron in that state when it is revolving in that state. So these quantities which I can measure, they are called as observable or physically measurable quantities. So next we are going to define these physically measurable quantities. That will be the second postulate. Third, आपने define तो कर दिया, okay. We are going to represent these physically measurable quantity in terms of operators. Operators के term में लिखोगे, for momentum operator you will have position operator, energy operator you will have, angular momentum operator you will have, and many more operators which have their operators are defined to do various purposes, for different purposes. So you are going to do that thing, that measurement with the help of operators. So next is measurement. So when you will operate these operators over these wave functions, then by this process you are going to measure that physically measurable quantity. So in this way we are going to move one by one. But before that, we are going to discuss questions of it. There was a question that was asked in JEST 2017. Please write. JEST 2000 questions based on this first postulate. What is the dimension of H cross upon I, del psi by del x? What is the dimension of H cross upon I del psi by del x? Where psi is a wave function in 2 dimensions. Where psi is a wave function in 2 dimensions. 2 dimensions. And 4 options were there. Option A, please find, मैं options लिखता हूँ, kilogram, meter -1, second -2. Option B, kilogram, second -2. किलोग्राम पर सेकेंड. ठीक है, बताइए बेटा. बोलिए. डी विल बी द आंसर. ओके, ये कितना है? एच क्रॉस. एच क्रॉस का यूनिट क्या होता है? ई इक्वल टू एच क्रॉस ओमेगा. ओमेगा इज पर सेकेंड, सो जूल सेकेंड. सो इसका यूनिट कितना होगा? जूल सेकेंड. सेकेंड इज टी. ठीक है, जूल कितना हुआ? एनर्जी. एनर्जी इज 1/2 mv स्क्वायर. सो mv स्क्वायर m l स्क्वायर ml स्क्वायर और t माइनस 2 मीटर पर सेकेंड हुआ mv स्क्वायर, so मीटर स्क्वायर पर सेकेंड स्क्वायर एंड दिस विल बी t। तो कितना हुआ बेटा h क्रॉस का ml स्क्वायर t माइनस 1। ठीक है, नाउ दिस साई का भी कितना कैलकुलेट किया 1 बाई लेंथ, so it will be divided by length. This length is here, so this will be kilogram mt minus 1. So ये कितना हुआ बेटा किलोग्राम सेकेंड माइनस 1. So option D. ऑप्शन डी राइट। नेक्स्ट क्वेश्चन। हाँ जी, किसका? एच क्रॉस का बेटा देखो किसी से भी देख सकते हो, बट मुझे ये याद रहता है, इजी है। एच क्रॉस ओमेगा, तो ये तो जूल हो गया और ये पर सेकंड हो गया, इधर इधर ले जाओ तो एच क्रॉस का कितना हुआ जूल सेकंड। जूल का लिखने के लिए सबसे अच्छा क्या है 1/2 mv स्क्वायर। ठीक है, तो m कितना हुआ किलोग्राम, v स्क्वायर मीटर स्क्वायर और सेकंड माइनस 2, 1 second is here, so in this way you can write. लिखिए नेक्स्ट क्वेश्चन। दिस क्वेश्चन वाज आस्क्ड इन जेस्ट 2012 जेस्ट 2012। the quantum state sin x plus e to the power iota phi cos x and this is ये x है बस cos x, this is the state that is given where this is 0 and ठीक है, the quantum state this one where this is 0 and this is 1 comma and x and phi are real and x comma phi are real comma again is orthogonal to four options were given. So this will be sin x, option B cos x plus e to the power iota phi sin x, option C minus cos x, this one minus e to the power minus iota phi sin x, it will be like this, option D minus e to the power minus iota phi cos x plus sin x, बताओ which will be the answer. So this state is given, you write it as psi 1. ठीक है, I can write it as psi 1. This is cat vector, this is, I write it. So what is the orthogonality condition? means if they are psi 2, then psi 2 over psi 1 it will be 0. So किसी वैसे ये आंसर है, मैं इसी को करके दिखाता हूँ. आंसर इज डी. यू कैन डू फॉर अदर. So this is what this is the answer. D is the answer. I just want to show you that this is given. This is psi 2. This state is given to me. Okay. So what you are going to find out? You are going to find out its corresponding bra vector. So that will be psi 2 like this. Make it ये complex कर दो बेटा. ये complex conjugate लो. तो minus e to the power iota phi, and this will be cos x, and this will convert into corresponding bra vector plus sin x and corresponding this will be. Now find out psi 2 over psi 1. Now find psi 2 over psi 1. Psi 2 over psi 1. So 4 combinations will be there. So first this one operating over this one. So that will be 1. ठीक है. आप एक्चुअली ये स्पिन का क्वेश्चन है. दिस इज अप स्पिन, दिस इज अप स्पिन. ठीक है. So up spin operating over up spin, you will get 1. This is given. So इसे और इससे multiply करो. So what you are going to get? You will get minus e to the power iota phi sin x cos x. ठीक है. और ये जो है ये 1 हो जाएगा. This will be up state acting over up state. When you are operating this one over second one, this will be 0. Next, this one acting over first one will be 0. This is going to operate over this. So this will again plus e to the power iota phi sin x cos x. This will be up vector, sorry, down vector. This will be down vector, and this will be, this is 1. This is 1. ठीक है ना. So this will be equal to 0. So psi 2 over psi 1 is 0. So this state, this psi 1 and this D option, they are orthogonal to each other. They are orthogonal. So option D was correct. Option D was correct. Next question. If the probability that x that x lies the probability that x lies between x and x plus dx. The probability, if the probability that x lies between x and x plus dx is px dx, sorry, equal to a e to the power minus ax. It is the probability that x means position. ठीक है. If the probability that x lies between x and x plus dx is this one, where x lies between 0 to infinity and a greater than 0. Then the probability that x lies between x1 and x2, then the probability that x lies between x1 and x2 in bracket x2 greater than x1, in bracket x2 greater than x1 bracket close is कितना होगा? 4 options were there. e to the power minus ax1 minus a minus a x2, option B, a e to the power minus ax1 minus e to the power minus ax2, option C, e to the power minus a x2 e to the power minus a x1 minus e to the power minus a x2, option D, e to the power minus a x1. This will be. So what will be the probability? Probability P will be, this is the probability to find out x in this range. So this will be px dx from x1 to x2. Substitute this. So this will be, a will be here. It will be e to the power minus ax dx. And this will be x1 to x2. Option A. Okay? So which will be option A? इसे integrate करो बेटा, what you are going to get? You will get a upon minus a. And here it will be e to the power minus ax2 minus e to the power minus a x1. So a is going to cancel out, minus sign will interchange these two. So option A will be the correct answer. So they have given you the probability in between x and x plus dx. So that is in that infinite decimal region. Now you have to find out probability from x1 to x2. So just integrate this. Okay? Just integrate this. Next question. The normalized state of a free particle is, the normalized state of a free particle is represented by wave function psi x comma 0 equal to n e to the power minus x square upon 2a square plus iota k naught x. Iota k naught x. Find the normalization constant. Find the normalization constant. Find the normalization constant. करिए जरा, simple question है. So this will be, n square will be here. ठीक है? It will be psi star psi. ठीक है? Here it will be psi star psi. तो कितना हो जाएगा? e to the power minus x square upon 2a square. Its complex conjugate is minus iota k naught x. Psi will be here e to the power minus x square upon 2a square plus iota k naught x dx, it will be equal to 1. So ये जो ये है ना, this part, it is going to cancel out by this. And what you are going to have, you will have n square. Limit will be minus infinity to plus infinity, integration minus infinity to infinity e to the power minus x square upon a square dx equal to 1. This will be n square. ठीक है? ये कितना होगा? This will be 1 upon, this is 1 by a square. कितना पावर है इधर? x to the power 0. So this will be 0 plus 1 by 2 and gamma 0 plus 1 by 2. This will be 1. ठीक है, so this is A only, so this will be n square, this will be A, this will be root pi, and this will be 1. So from here normalization constant, this will be equal to कितना होगा बेटा ये, this will be 1 upon a to the power 1 by 2 and pi to the power 1 by 4. This should be the answer. This is normalization constant. Next question लिखिए. लिखिए. This question was asked in GATE 2005. Next question. A system in a normalized state. Please write next question. कैसा, ये तो इवन फंक्शन है. नहीं, अगर आप इवन फंक्शन इसे वैसे करोगे तो कितना हो जाएगा, 2 आ जाएगा इधर, तो 0 to इनफाइनाइट आ जाएगा. तो 0 to इनफाइनाइट के लिए यहाँ पे 1 by 2 का फैक्टर भी आता है. क्यों? रूट टू क्यों आया, रूट टू कहाँ से आया? लेकिन वो जब आप 0 to इनफाइनाइट करोगे तो फॉर्मूले में 1 by 2 होता है. अगर आपका लिमिट 0 to इनफाइनाइट है तो आपका 1 by 2 का फैक्टर होता है, और अगर आपका माइनस इन्फिनिटी टू इन्फिनिटी है देन इट विल बी, तो फिर आपका 2 नहीं होगा. देखो ये जो मुझे फॉर्मूला पता है मैं लिख देता हूँ बेटा इधर, माइनस इन्फिनिटी टू इन्फिनिटी x to the power n e to the power minus alpha x square dx. This will be simply equal to 1 upon alpha to the power n plus 1 by 2 gamma function of n plus 1 by 2. बट ये कब होता है? when n is even number. अगर n even number, ठीक है. तो अगर n इवन नंबर है और आप इसे लिखते हो, कभी कभी जरूरत क्या पड़ता है, 0 to इनफाइनाइट x to the power n and e to the power minus alpha x square dx. So this will be half here alpha to the power n plus 1 by 2, ठीक है, and gamma function n plus 1 by 2. तो वो इधर से ही आया, इसे आपने 2 टाइम्स कर दिया तो इधर आ गया, ठीक है. तो कैसे भी लिख लो. गेट 2005. नेक्स्ट क्वेश्चन. अ सिस्टम in a normalized state. A system in a normalized state, psi equal to C1 alpha 1 plus C2 alpha 2. ठीक है. तो जो IIT जैम के बच्चे हैं ना, पर्टिकुलरली इन द जैम एग्जामिनेशन, जेस्ट और उसमें तो ऐसा ही रहता है, जेस्ट और TIFR में ऐसे ही आना है फॉर देम ऑल्सो, बट फॉर जैम स्टूडेंट वो क्या करेंगे, इन द एग्जाम दे विल गिव यू लाइक दिस. यही क्वेश्चन अगर मुझे जैम में देना हो देन आई विल राइट लाइक दिस. तो बोथ आर सेम, ठीक है. सो वो इस अल्फा 1 को phi 1 लिख रहा है, अल्फा 2 को phi 2. सो उससे कंफ्यूज होने का जरूरत नहीं है. लिखिए, वेयर cat alpha 1 and cat alpha 2, where cat alpha 1 and cat alpha 2 representing two different eigenstates, representing two different eigenstates of the system, representing two different eigenstates of the system, comma, requires that requires that the constants C1 and C2 requires that the constants C1 and C2 must satisfy the condition. Must satisfy the condition. This is C1, C2 equal to 1. Option B, C1 plus C2 equal to 1. Option C, C1 plus C2 whole square of this is 1. And D, C1 square plus C2 square equal to 1. हाँ, ऑप्शन डी लिखिए बेटा, पहले आंसर लिखो इसका. इन क्वांटम मैकेनिक्स वी चूज, प्लीज राइट. अभी सारी चीजें एक साथ पढ़ा नहीं सकते, बट क्वेश्चन में यूज हो जा रही हैं, सो आई एम डिक्टेटिंग. इन क्वांटम मैकेनिक्स वी चूज आइगन स्टेट्स ऑर्थोनॉर्मल. वी चूज आइगन स्टेट्स ऑर्थोनॉर्मल. तो ऑर्थोनॉर्मल आइगन स्टेट्स चूज करते हो आप. सो बेसिकली इफ यू आर डूइंग अल्फा 1 एक्टिंग ओवर अल्फा 1, दैट विल बी 1, and alpha 1 acting over alpha 2 will be 0. ठीक है. So what is the meaning of orthonormal? It means alpha 1, if it is acting over alpha 1 or alpha 2 acting over alpha 2, this will be 1 beta. But if alpha 1 is acting over alpha 2 or vice versa, alpha 2 over alpha 1, this will be 0. ठीक है ना, this will be 0. So there you are going to choose eigenstates. Wherever eigenstates will be, they will be orthonormal. So what it will be? So you are going to find out this psi over psi. ठीक है, this should be 1. ठीक है, if it is a normalized state, then it should be equal to 1. So इसका ब्रा वेक्टर कितना होगा? दैट विल बी साई. इट विल बी लाइक दिस. दिस विल बी C1 स्टार एंड इट विल बी अल्फा 1 प्लस C2 स्टार. दिस विल बी अल्फा 2. सो फर्स्ट वन is acting over first one, C1 star C1. So this will be C1 square. The second one acting over second one, you are going to get C2 star over C2. So this will be and this will be 1. This is the normalization condition. So answer is D. Okay, they may be simple questions, but we have to know everything. हाँ जी. ऑब्जर्वर्स को हम हार्मिशियन ऑपरेटर्स यूज कर रहे हैं.
मेजरमेंट होता है उसका जो आइगन वैल्यू है उसका, तो आइगन वैल्यू इसका मेजरमेंट.
बिल्कुल. अगर उसे मेजर करोगे,
इसलिए हम लोग हार्मिशियन ऑपरेटर चूज करते हैं क्योंकि उनको आइगन वैल्यू.
हाँ, सब बता दूंगा. ठीक है, पर यही है आंसर. क्या बेटा? यस बेटा. नहीं, क्या बोला बेटा? साई स्टार ओवर साई. ओके, ये दिस इज इक्वल टू, दिस इज नॉट मोड साई स्क्वायर. व्हाट इज दिस? दिस इज, ये जो है ना, टेक द स्टार ऑफ दिस and this one is without a star. Whatever space is there, suppose minus infinity to infinity, this will be 1. If you are having, suppose this is chi over phi, suppose you are having this, so this will be equal to whatever limits are there, you can apply the limits here. So this will be chi star x, second will be phi x, and this will be dx. Suppose I am providing limits from 0 to a. So this will be the scalar product. ठीक है ना? And scalar product क्या बेटा? dx is here ना? अच्छा यहाँ भी dx है. Okay. And it should be less than infinite. It should be finite. Next लिखिए बेटा.
क्वेश्चन में बोला है कि सिस्टम नॉर्मलाइज्ड whenever we have a system normalized then we also consider that system is orthogonal.
आइगन स्टेट्स की बात करो. अगर आइगन स्टेट्स की बात करो,
like alpha 1 and alpha 2.
देखो वो क्या बोल रहा है, ए सिस्टम इन ए नॉर्मलाइज स्टेट. तो जब वो बोल रहा है सिस्टम इन ए नॉर्मलाइज स्टेट, तो किसे नॉर्मलाइज बता रहा है? ही इज टॉकिंग अबाउट दिस स्टेट इज नॉर्मलाइज्ड. System is normalized in this state. So he is saying that this psi is normalized. So you know that this psi over psi is 1. ठीक है? And any of the state, later on in the next class I will come to this, any of the arbitrary state of a quantum mechanical system, it can always be written as the superposition of eigenstates. So these are the eigenstates alpha 1, alpha 2. So this is an arbitrary state which is normal, ठीक है, which is normalized, ठीक है ना. It can be written in terms of eigenstates. So alpha 1, alpha 2 are eigenstates. Because they are eigenstates, that's why I am choosing them orthonormal. ठीक है ना. Eigenstate in quantum mechanics we choose them orthonormal. तभी हम सुपरपोजिशन प्रिंसिपल ना अप्लाई कर लेते हैं बहुत इजीली. सो नेक्स्ट क्लास में बताऊंगा वो. नेक्स्ट अभी नेक्स्ट में भी पता नहीं, थोड़ा आगे चल के बताऊंगा. ठीक है, लिखिए नेक्स्ट क्वेश्चन लिखिए. द वेव फंक्शन, बट सब चीजें बता दूंगा, एवरीथिंग वॉट एवर यू नीड इन क्वांटम मैकेनिक्स. द वेव फंक्शन ऑफ ए पार्टिकल at a certain instant is given by, the wave function of a particle at a certain instant is given by psi x equal to a some constant exponential minus x square upon a square plus iota kx फुल स्टॉप. आगे लिखिए. इफ P1, कैपिटल P1 एंड P2, if P1 and P2 are the probabilities, if P1 and P2 are the probabilities of finding the particle, if P1 and P2 are the probabilities of finding the particle in the range A and A plus dA 2A and 2A plus dA. So P1 is the probability of finding the particle within this range, and P2 is the probability of finding the particle within this range, respectively. Then find the ratio P1 by P2. मुझे क्या चाहिए? P1 by P2 चाहिए. ये रेशो बताना. एंड आंसर्स आर, चलो आंसर बताओ ऐसे ही. इट वॉज गिवन लाइक दिस, एग्जैक्ट याद नहीं है मुझे, बट इट वॉज समथिंग लाइक दिस. 4 e to the power 6 e to the power 8, इस टाइप. ऑल दीज क्वेश्चंस दे आर आस्क्ड इन एग्जाम. ये नॉर्मलाइजेशन वाला छोड़ के बाकी सब एग्जाम के क्वेश्चंस हैं. करिए. So this is the probability P1 of finding the particle in an infinitesimal element. ठीक है, दिस इज ए इनफाइनेटसिमल एलिमेंट. कितना होता है प्रोबेबिलिटी ऑफ फाइंडिंग द पार्टिकल इन एन इनफाइनेटसिमल एलिमेंट? x एंड x प्लस dx के बीच में psi square dx. This will be psi square dx. So it will be how much? This will be psi where at x equal to a square of this and dA. This will be. What will be P2? P2 is the probability of finding the particle within this infinitesimal element. कहाँ से कहाँ तक है? 2a से शुरू हुआ और 2a plus dA तक है. ठीक है, तो लेंथ कितना है इसका? dA. Length is dA. So it will be psi square. So what will be x here? X will be 2a. But length element is still dA. This will be. This is the probability. In this way, we have defined the probability, the Born approximation. ठीक है? So this will be dA. This is going to cancel out. Psi square. देखो इसे देखो psi square करोगे. This will be a square here. ठीक है? So you are going to have a square here. And you are going to have a square here. When you will multiply this by its complex conjugate, this iota part is gone. And what you will have? E to the power minus 2 times x square upon a square. X का value कितना है? A. So this will be 2a square upon a square divided by here. Again you are doing the square. So it will be again a square is here, e to the power minus 2x square upon a square. But x कितना है? 2a. So what it will be? It will be e to the power minus 2. This will be 2a square upon a square. ठीक है, तो ये तो कैंसिल हुआ और ये भी कैंसिल. e to the power minus 2 here divided by e to the power minus 8. So answer will be e to the power 6. So this was a very good question, very simple definition based on definition. लिखिए next question. This is given in your assignment. लिखिए find the eigenstate. Find the eigenstate of momentum operator. Find the eigenstate of momentum operator px. ठीक है, इक्वल टू माइनस आयोटा h क्रॉस d by dx. Find the eigenstate of momentum operator, this one, full stop. If eigenvalue is lambda, if eigenvalue is lambda, which is given by the relation, px acting over phi equal to lambda phi, where lambda equal to h cross k. तो आपको आइगन स्टेट ऑफ मोमेंटम ऑपरेटर बताना है. अभी आपको कुछ नहीं पता है मोमेंट. एवरीथिंग ही हैज गिवन इन द क्वेश्चन. ही इज सेइंग फाइंड द आइगन स्टेट. बस इतना पता है स्टेट इज रिप्रेजेंटेड बाय द वेव फंक्शन. तो मुझे वेव फंक्शन निकालना है. कहाँ से निकालना है? दिस इक्वेशन इज गिवन. ठीक है, सो दिस इज आइगन वैल्यू इक्वेशन. लेटर ऑन वी विल से इट आइगन वैल्यू इक्वेशन. एंड व्हाट दिस इक्वेशन इज एक्चुअली टेलिंग, अभी ऐसे ही बता रहा हूँ. दिस इज ऑपरेटर. You are operating this operator over this state. ठीक है, और यहाँ क्या मिलेगा, जो मोमेंटम का वैल्यू होगा, पार्टिकल विल हैव सम मोमेंटम इन दिस स्टेट, तो वो जो वैल्यू पॉसिबल होगी दैट विल बी हियर। ठीक है, सो लैम्डा क्या है, लैम्डा इज एक्चुअली अ रियल नंबर। लैम्डा इज एक्चुअली, मोमेंटम क्या होता है, मोमेंटम तो कुछ रियल नंबर होगा ना, बट मोमेंटम may have two different values. One, particle is moving in this direction, so you write it plus. If I am assuming in this direction is x cap direction, so my particle is moving in this direction, so my momentum may be positive. If my particle is moving in this direction, my momentum will be negative. So two possibilities are here. ठीक है, so momentum may be positive here, momentum will be negative also. Both the possibilities are there. So this is just the starting, तो इसलिए starting में ऐसा लग सकता है, but these are very common things. थोड़ा सा कोर्स आगे बढ़ेगा, you will be well aware about all these things. So how you are going to find out phi? In place of px write this, जो given है minus iota h cross d phi by dx. You write it as 1, और 1 के साथ में लिख लो if lambda is positive. If lambda is positive, तो ये कितना होगा, अगर मेरा लैम्डा पॉजिटिव है, देन आई विल राइट h क्रॉस k एंड दिस विल बी 5 बेटा, दिस विल बी 5. ठीक है, नाउ दिस इज अ डिफरेंशियल इक्वेशन, यू हैव टू सॉल्व दिस. तो h क्रॉस इज कैंसिल आउट फ्रॉम बोथ साइड्स एंड दिस विल बी d phi upon 5 will be here, and on this side this minus iota is here, so iota square by iota, this will be iota k into dx. यही होगा बेटा, iota k into dx. So this will be log phi, natural log of phi. Integrate this equation. Here it will be iota k x, and because we are not providing the limit here, you can use here some constant, so I am using log a, where a is a constant. So bring this log a on this side, this will become log phi by a. So what will be your equation? This will be phi by a equal to e to the power iota kx. So phi will be equal to a e to the power iota kx. So actually this is the eigen state of the momentum operator. Agar something is moving in this direction, in the x direction, try to understand. Suppose your wave is or your particle is moving in this direction, ठीक है, particle is moving in this direction, then this will be the wave function. आपने बहुत टाइम इसे यूज किया होगा when you were doing your बेसिक क्वांटम मैकेनिक्स कोर्स, इवन एट ग्रेजुएशन लेवल. जब आप लिखते हो ना ये बैरियर पोटेंशियल प्रॉब्लम और स्ट्रैप पोटेंशियल, यू ऑलवेज यूज दिस. Actually this wave function is telling me that my wave function, this part of the wave is propagating in plus x direction. कैसे पता चलेगा कि this is representing in plus x direction? ओके, देखते हैं कैसे पता चलता है. दिस इज 5, वी आर राइटिंग ए e to the power iota kx. If this is representing the part of the wave that is propagating in plus x direction, then momentum associated with it should be positive. तो जो इसके साथ मोमेंटम एसोसिएटेड होगा दैट विल बी पॉजिटिव. मोमेंटम कैसे मेजर करोगे? By this operator. This is momentum operator. So if I operate this operator px over this state phi, px is minus iota h cross, this will be d by dx, acting over this A e to the power iota kx. Okay, so what you are going to get minus iota h cross is already here. When you will differentiate this, iota k will also be there. Iota k will come into the picture, and rest thing A will as it is, e to the power iota kx is as it is. So iota is square minus 1. So what you are getting? You are getting plus positive value of the momentum, and this is phi. That's why you are using, whenever a part of the wave function is propagating in the plus x direction, you can represent it by this a e to the power iota kx. ठीक है? Next, इसका second part है. Second part you can write. Suppose you can write if lambda is negative. If lambda is negative, then लैम्डा नेगेटिव होगा तो कितना हो जाएगा माइनस एच क्रॉस के. सो माइनस विल बी हियर, यहाँ पे माइनस आ जाएगा. सो माइनस विल बी हियर. सो दिस विल बी माइनस हियर, दिस विल बिकम माइनस. ठीक है. सो जैसे है ना, कब यूज करते हैं इसका, सपोज यू आर हैविंग ए स्टेप पोटेंशियल. ठीक है, दिस इज जीरो एनर्जी, दिस स्टेप पोटेंशियल इज ऑफ हाइट v नॉट. सपोज you launched a particle whose energy is less than this v naught. Then what will happen? इसके साथ एक wave associated होगा. A wave character is associated with it. What is the property of the wave character? Whenever a wave character observes an interface, there is this particular property is associated with any of the wave. If a wave character is observing an interface, a part of it will be reflected back, a part of it will be transmitted into another medium. So what is going to happen here? In this region, a part of the wave will be like this, that is moving in the forward direction. A part of it will be reflected back. So in this region, two part of wave function will be there. Here in this region, your wave function will be made up of two parts. One part of the wave is propagating in this direction, you have launched from this side. Another will be moving in this is representing the reflected part of the wave. So this forward moving part, it is represented by this, you write it as a e to the power iota kx. A part is reflected back, it is moving in negative direction. So its momentum associated this with this should be negative. That will be this one. Operate over px. जैसे यहाँ operate किया, I write it as phi 1. Suppose this is phi 2. So px operating over this phi 2. This will be minus iota h cross d by dx. And this will be b. यहाँ पे b लिख लो बेटा इसे. You write it as b. This will be b e to the power minus iota kx. So it will be minus iota h cross, and here you will get minus iota k, and this b will be there, exponential will be there, so I can write it as phi 2. So what you are going to get, minus minus plus and then minus h cross k, and this will be phi 2. So this part of the wavefront that is reflected back, that is moving in negative x direction, it can be represented by this wave function, this one. So you write it as b e to the power minus iota kx in this region. Here, when a part of it will be, this is reflected part, automatically a part will be transmitted like this. ठीक है. However, यहाँ पे वेव नहीं हो पाएगा ये, क्योंकि ये जो एनर्जी है ना ये कम है. So if I move it more simpler for you, suppose energy of the particle is greater like this. In that case, this will be physically classically accessible region. Try to understand. Classically forbidden region, classically allowed region. Classically allowed region is those region where kinetic energy is positive or zero, rest पे होगा. And classically forbidden region are those region where kinetic energy is becoming negative. तो यहाँ पे मैं क्यों नहीं लिखा, अगर मैंने E को कम कर दिया, in this region my potential energy is V naught, energy is less, so kinetic energy become negative. ठीक है. So classically particle cannot exist, but here in this case due to the wave character associated with the particle, यहाँ पे wave character तो नहीं होगा exactly, but a decaying wave function will exist. But if I make this problem more simpler, I am saying this energy of this particle is greater than this V naught, then problem is no problem. Here energy is positive, this much energy is there, and here this will be the kinetic energy, positive kinetic energy. So now wave character may exist here in this classically allowed region. In classically forbidden region, exponentially decaying solution will be there. I will find out later on. But in classically allowed region, wave character, proper wave character will be there. So this is in which direction this is moving? This is moving in the forward direction. So this will be simply, you can write, this will be C e to the power iota, k number is going to change. So I will write it as k1 and this will be x. So in this way you can write. If I create a barrier also again here, I am saying a barrier is here. So this is going to face this barrier again. So a part of it will be reflected back. So I will write here d e to the power minus iota k2x. So when it is striking here at this interface, a part of it is reflected back, a part of it is transmitted here. Again, this is forward moving, so I can write it as e to the power iota positive, and this part and this part, they are having same potential, 0. So k will be same, so this will be kx. This will be simple. So in this way you can write down the wave functions in different regions later on 1D problems. So these are called phi 1 and phi 2. You can write phi 1 and phi 2 are the eigen functions for the momentum operator. Are the eigenstates or eigenfunctions of the momentum operator. ठीक है. इसे बेटा आप P के फॉर्म में भी लिख सकते हो. P कितना होता है? H क्रॉस K. ठीक है. P is H cross K. So here in place of K you can write iota minus iota P x by H cross. So I can also write them in terms of P also. तो P के फॉर्म में कितना होगा? phi 1 it will be a e to the power iota P x upon H cross. Phi 2 this will become b e to the power minus iota px by H cross. P कितना होता है मोमेंटम? This will be H cross K. दोनों का यूज करते हैं. एक्चुअली देयर आर टू डिफरेंट स्पेसेस. ठीक है ना. वैसे 3 स्पेस हैं. एक वन इज एक्सिस स्पेस और पोजीशन स्पेस you call. We solve the problem in position space. Second is momentum space. Many of the problems sometimes they say that solve the problem in momentum space. There is third one, K space. You can also solve the problem in K space. K space and P space more or less they are same. ठीक है. So slowly and slowly we will learn. So this is the thing. This was the question.
K1 and K2 are same.
हाँ, ये K1 कहाँ पे बेटा? ये तो K2 होगा. इससे बेटा देखो यहाँ पे K अलग होगा, यहाँ K अलग होगा, तो कुछ भी ले लो. इसे K1 लेना है तो फिर ये K1 ही हो जाएगा. ठीक है. और यहाँ पे K हो जाएगा. दोनों सेम होंगे. नाउ लिखिए. Which of the following wave functions shown in the figure? Which of the wave functions shown in the figure can have physical significance? Which of the wave functions shown in the figure can have physical significance in the interval shown? Which of the wave functions shown in the figure can have physical significance in the interval shown, and why? And why? So, first case. So, this is x-axis. This is A, this is 0, this is capital A, and this is your wave function. You can write it as psi 1x. So, psi 1x is A. What is psi 1x? Psi 1x is A. You have to tell me this is acceptable wave function or not. Within the range, 0 to A. देखो, in between 0 to A, it is single valued. At every point, it is having a single value. Second, it's finite at every point. ठीक है, constant है, constant is a finite number, A number is constant. ठीक है, it is continuous, discontinuity तो कहीं है नहीं इसमें. Third is also, and this is square integrable. ठीक है, square integrable आप करो इसे integrate 0 to A. This will be A square into dx. So how much you are going to get? This will be A square. And this will be dx का integration कितना हो जाएगा x. So this will be A square into A. This is finite, less than infinity. So this is square integrable. ठीक है, square integrable wave function, but within the limit 0 to A. So this is acceptable wave function. Second was this one. This is unacceptable. This is not acceptable. It is double valued. At every point, at this point, you are having two different values. One is this, another is this. This will give some another probability. This will give you another probability. Okay? So, this is not acceptable. This is not single valued wave function. This is not single valued wave function. Third, something like this. This is psi x. Psi x, this is 0. This is not acceptable. Actually, if you find out its slope here, ठीक है, ये जो point है ना, ये थोड़ा सा ऐसे था कुछ, तो इसका यहाँ पे जहाँ slope का discontinuity है, there is a discontinuity in slope. Multi-valued, ठीक है, multi-valued भी है. If you look here, अगर इसे मैं थोड़ा और सही कर दूँ, if I make it like this, चलो इसका multi-valued हटा देते हैं. I make it like this. So there is a discontinuity in slope. So this is discontinuous. So this is not acceptable. This is not acceptable wave function. Next, fourth. this one of example was this. This is discontinuous at, it is becoming infinite actually, not finite values. So at b, at x equal to b, this is infinite, this blowing up to infinity. So this is not acceptable. Fifth, this is b, this is a, this will be 0, this will be x. ये बताओ, सिंगल वैल्यूड है, फाइनाइट है, ठीक है ना, और स्क्वायर इंटीग्रेबल भी है. स्क्वायर इंटीग्रेबिलिटी कैसे देखो, एरिया से. स्क्वायर इंटीग्रेबिलिटी एरिया से चेक कर लो बेटा, ठीक है. साइज स्क्वायर होगा, सो दिस विल बिकम पॉजिटिव, निगेटिव से पॉजिटिव हो जाएगा. शेप विल बी मोर लेस दिस, स्क्वायर करके कुछ ऐसे बनेगा, ठीक है. सो एरिया विल बी देयर, पॉजिटिव एरिया विल बी देयर. So this is square integrable and continuous everywhere. So this is acceptable. Fifth one is acceptable. Sixth one. This is discontinuous. This is discontinuous beta. So this is not continuous. So this is not acceptable. So this first and fifth, they are acceptable. First and fifth are the acceptable wave function.